Spatialization is typically used for sounds that come from a specific source. In course 1, we discussed how we may actually turn it off for some room tones or area loops, since it can feel odd to have these panning around you. For some sounds, it makes sense to have them spatialized up to a certain point, but when you get close to them, to switch to being non-spatialized, so that we get the impression that the sound is all around you. For other sounds, you may want them to actually appear in-game as stereo sources. We'll look at the attenuation spatialization settings that will allow you to achieve both. So far, we've used mono sound files for spatialized source sounds and stereo files for area sounds or room tones that are not spatialized. However, there may be instances where you want stereo sounds to appear as spatialized in the game as a stereo source. If we add a stereo sound to the level through an ambient sound actor and set the attenuation within the actor itself, so override attenuation, then we can see how it's treated by default. What I'm going to do is to switch on the audio 3D visualize so you can see that source here. And you might notice a red icon on the left and a green icon on the right. Those are the two channels of our stereo source. And you can see by default they're quite close together. So as we're right up against it, we can hear that sound in stereo. But as we move further away, that sound quickly becomes folded down to essentially what sounds like a mono source. So let's just delete that ambient sound actor for the moment and come down this end of the cave. We've got some magical sound effects here where we want that stereo spread to be maintained. So in the details panel, attenuation spatialization here, you can see we've set 3D stereo spread to 850 units. So we can see here again the left channel represented by the red on the left and the right channel by the green on the right. So those are our stereo sources, and if you listen you can clearly hear it as a stereo sound. And as we move away, that stereo effect is just being maintained over a greater distance. And one thing we need to be careful of is that as we increase our distance from a stereo sound source, the separate channels increasingly sound like a point source, so that both the left and the right may at some point appear in the same speaker. This is known as channel summing, so it's a sum of both channels together. The issue that can arise here is that if both channels are at full range, in other words, if they're both loud sounds, when we combine these into the same channel, it could potentially produce audible clipping. So that's what this normalized 3D stereo sounds option is for. It applies a -6 dB reduction in order to avoid this happening. The spatialization method here is set to panning, but we do have some control over how this is handled. In our project settings, engine, audio, if we go down here to the quality section here, we've got this option for panning method. When panning linearly between speakers, the signal is at full gain in the left speaker when fully panned to the left, and at full gain in the right speaker when fully panned to the right. This appears logical, but it causes the sound to always be quieter when panned to the middle, since the signal is being sent equally to the left and right channels. The equal power option here is an attempt to mitigate this effect by using a nonlinear approach. Another spatialization option you might want to experiment with is the non-spatialized radius. In terms of spatialization, the audio system by default treats mono and stereo sounds as if they're coming from specific points in space. But for larger sounds, this may not feel right. For this sound, you can see that we've set this non-spatialized radius to 2000. This means that from a distance of 2000 units away, the sound is going to start to become non-spatialized. In other words, the sound will start to bleed into all channels of whatever speaker configuration you're using, be that stereo, 5.1 or 7.1. So the sound starts to come from all around you. This is going to give a more convincing sense of scale for these large sound sources, such as this waterfall. So at a distance here, you can clearly hear the sound is still spatialized. As we get right up against it, we want that sound to feel all enveloping. So at that point, we're within that 2000 distance, and what you could hear was that the sound started to come from all the speaker channels. Using the non-spatialized radius option is also a good idea for sounds that move around, since it can avoid the popping effect you can sometimes get when a sound passes through the player, suddenly whipping from one speaker to another. In Cave 6, as we enter, there's this trigger volume here that sets off a little creature that flies by the player. We'll just find the reverb for this cave and just disable it temporarily so we can hear it a bit more clearly. And we'll solo the sound cue. Audio solo sound cue creature. So I'm going to walk through this trigger. We can hear this little creature that flies towards the player and past it. If we listen for a moment, you should hear that whipping, popping type effect as it moves from very quickly from one speaker or headphone to another. So what we might do in those instances is find the sound source here and make sure that we apply some non-spatialized radius there to avoid that whipping type effect. We've seen how spatialization does not need to simply be on or off. We can spatialize sounds only when we're within a given distance from the source, and we can spatialize stereo sources within the game.